Okay, so the assigned homework problem last night was if 9.47 grams of iron 2 fluoride is reacted with calcium chloride, how many grams of calcium chloride we need to do completely react with iron 2 fluoride? Okay. Alright, let's see. So we have, starting with 9.47 grams of iron 2 fluoride. We need to figure out the formula for iron 2 fluoride. Iron 2, the name iron 2 means that we have iron with a 2+ charge on it. Okay? And then fluoride, the IDE ending means in the case of an ionic compound like this that we have a fluorine just by itself but with some kind of negative charge. IDE endings in an ionic compound mean you have a negative charge on that monoatomic particle. So we need to know the charge on the fluorine. And let me get some test references over here. Did that stop the camera? I don't believe that. Okay. No, it didn't. Okay. That was just the... Alright, so here is the periodic table with oxidation numbers. Okay. And fluorine has one negative charge. Okay. So one negative charge, and so in order to get all this to work out, this has a 2+ and a 1 negative here. And the way we put it together is we've got to know what coefficients to put there and there, such that we add all that up together to get a 0 charge when we're done. So we need a 2 here and a 1 here. So that means we also need a 2 in front of the fluoride. And we add those together and actually show them bonded together in a formula. Then we're going to make this 2 as a subscript to show it's part of the bonded formula. So we're going to have 1 Fe and fluorine with a subscript 2 to show that it's a bonded formula. Okay? Alright, so now we know the formula that goes up here, and that's FeF2. Alright, so that's our starting amount, and we're going to put it over 1. Alright, yesterday we said that the way you get from the mass of one substance, as the problem asks for, starting with the mass of one substance, how do you get the mass of another? We're starting with iron 2 fluoride, and we're trying to get to the mass of calcium chloride. We can't get there directly, we said. What we have to do is to convert the mass of whatever your starting amount is, so that we're going to start with the mass of iron 2 fluoride, and from that we're going to convert to moles of iron 2 fluoride. And the way you convert from one to the other is to use molar mass to get there. Okay, so to go from iron 2 fluoride to moles, you have to go through or use molar mass. Okay, once we have the moles of FeF2, then we've got to get to the moles of the stuff we're trying to find, which is calcium chloride. I guess I could go ahead and show you how to balance that one, but I've shown you how to do it. You should know how to do it, but I'm going to give you the formula here. There's calcium chloride. And the way that we get from here to here is to, move this marker out of the way, is to use what's called the molar ratio. Okay? So to get from moles of FeF2 to moles of calcium chloride, we have to go through this molar ratio. Then finally, since the question is asking us for the mass of the, in grams, it says how many grams, that's the mass. What the mass of the final product is, then what we want at the end is the mass of calcium chloride. Anytime we're going from moles to mass, we're going to go through molar mass. So to get from moles of calcium chloride to the mass of calcium chloride, we go through molar mass. And that's the problem solution process for a problem like this. Okay? All right. So the first thing we need to do then to get from mass, which is what I have up here, mass of iron 2 fluoride, to get from mass to moles of iron 2 fluoride, I have to calculate the molar mass. And molar mass, by definition, is the sum of all the atomic masses of all the atoms in the formula written in units of grams. And in this class, you also have to show that equal to 1 mole of that same species. All right? So then we're going to have to get the mass of iron here from the periodic table, 55.845. And we've got 2 fluorines, and fluorine has a mass of 18.9984032. We need 2 of those. Okay, so we need to show that that's what those masses are. Okay, this is kind of like taking good or writing good observations and keeping up with everything in the lab. These are getting complex enough that if you don't keep up with the labels on everything, if you have an error or a problem, you can't go back and figure out what you did. Or it's hard to, so you need to label everything. I expect you to see the symbols out here next to those atomic masses. So we're ready to add these up together because the definition is the sum of the atomic masses. So 55.845 plus 18.9984032 plus 18.9984032. Okay, and I get 93.841 8064. Okay, and we've got 4 empty slots at the top. 1, 2, 3, 4. So the numbers resulting from those columns of digits then are going to be rounded off. This is going to be grams of FeF2, and we're going to round that then to 93.842 grams of FeF2. So that's what we said we had to have for the sum of all the atomic masses of all the atoms in the formula written in units of grams. But I also said that in this class, you have to show that equal to 1 mole of that same species. Okay? So this is what's required for calculating molar mass in this class, Dick. Okay? I need you to sit up, buddy. Okay? Jasmine? I'm sorry, that's not Jasmine. You're over there. Right? Okay. Christian. Had to stop and think. Not Kristen, but Christian. Okay. Okay? Patty. Huh? Doesn't matter. Sit up. Okay? Alright, so then from this equality statement then, we can build a conversion unit up here. Alright, we want the side of the equality statement that matches this starting amounts, units, and species to be on the bottom of this fraction. And that's 93.842 grams of FeF2. This is the side that matches the units of our starting amount and matches the species of our starting amount. Okay, and so the other side of the equality statement goes on the top. 1 mole of FeF2. Okay, so now we're ready to cancel, like x's and y's in algebra. Grams and the species can cancel on the top and bottom. We're ready to do the math now. We take this number and divide by this number in the calculator. 9.47 divided by 93.842, and I get 0.1009143028. Okay. Well, let me check my math here. 9.47 times 93.842. I mean, divided by 93.842. Huh? Well, you may have had a math error here. Is that what you're talking about in the molar mass calculation?
No, I had that right. So I divided on 9.47 and that number, so I'm going to get 9.9.
Well, you must have put it in your calculator wrong or something. You know, you need to double check your math. Always do your math twice, okay, to be sure. All right. Or one way to be sure, too, is when you have one of these graphing calculators. That's the beauty of having a graphing calculator. You can actually look at the math you put in there and make sure you did it right, okay? If you don't have a graphing calculator, then you need to do your math twice to be sure you've got it right. If you don't get the same answer twice, then you assume you did something wrong. Okay? All right, so we've got 3 digits in our first number, and when we're doing rounding of multiplication and division problems like this, we look at only the measured numbers and the calculated numbers, not at these counted numbers here and here. Only the measured and calculated numbers, and then choose the number that has the least digits. That's this one, and make your final answer match that number of digits. Leading zeros are not significant, so our first significant digit is the 1, and these two are significant, so we underline everything after that. We're going to round it off to 0.101, I heard Shane say. Okay, and there's the answer for this first stage of this solution to our overall problem. Huh? Oh, I did leave off moles. Where in the world? What am I doing? You're right. You're right. It is points off. Okay. 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 So that's the first stage. Now we've got to go through the other 2 stages here. We've successfully gotten from mass of FeF2 to moles of FeF2. And now we're ready to go from moles of FeF2 to moles of calcium chloride.